Welcome everyone. This is Training and AutoML Walking Room Community Call on 19th of March. This meeting will be recorded and published on YouTube. This meeting is governed by the Kubeflow Code of Conduct. So maybe we can start this call with a quick introduction. Do we have any kind of new people here in the call just to introduce themselves to the community? Just want to say hello.
Okay, I can start. I'm Peter, and I'm Andrew's colleague here at Apple. And I work with tech support for customers, basically in a little kernel DevOps work. And I'm basically here just to educate myself on Kubeflow and the ecosystem around it. Nice to meet you all.
Thanks, Peter. Thanks for joining.
Welcome, Peter.
Anyone else want to say hello?
Hi, Angie. I want to introduce someone to you. Hi, Ximing. Do you want to introduce yourself to the folks? Ximing is a talented student in our school, and she learned from Kubeflow from me. And also, she's passionate about Kubeflow, eager to contribute to the Kubeflow. Do you want to introduce yourself?
Hello, I'm Ximing, and I'm from China, Shanghai Jiao Tong University, and I have do some small contributions to the Kubeflow community, and now I'm working on add manifests for the trainer, both the Kubeflow platform and the standalone installation, and I hope. Hopefully you can give me some suggestions on these two issues in today's meeting. Thank you.
Yeah, that's great. Thanks for joining, Doris. Nice to see you here. Feel free to ask any questions in Slack, or in GitHub if you have any kind of, onboarding discussions. Because right now we're kind of in the process of this new project. It's hard, I believe, for new folks to, get onboarded. So don't hesitate to just ask us any questions. How to get started. Anyone else want to say hello?
Yeah, I can introduce myself. Hi, I'm Nidish, and I'm from Rutgers University. I'm currently a junior studying computer science on the AI track, and I've been wanting to get involved with Kubeflow, and also I'm planning on participating in the Google Summer of Code. So there was a project I was planning to work on for that. I was planning on working on the JAX and the TensorFlow integration, and I've been looking into that. There isn't really much documentation on the V2 trainer. So I just wanted to ask if there was any way to get more introduced into that, more introduced onto what the SDK provides, because I couldn't really find much in the documentation.
Yeah, absolutely. Thanks for joining, Nitish. Yeah, so it's a hard question because like we're just getting started. But overall, like I guess we try to we have this getting started example in the Qflow docs. You can take a look. For the SDK side, you probably right now have to read the code, unfortunately. So I would suggest you maybe to check the V1 documentation because the SDK quite similar in terms of capabilities. And like the way how we interact with Kubernetes API, it is the same. In terms of the plugin approach and the like to support new frameworks like JAX, TensorFlow, so please take a look in the CAP that's myself and Yuki prepared in summer last year. So CAP has like the information around like what is the Kubeflow trainer, what is the runtime, why we're doing this, and I think it has really like a lot of useful information for you to understand. Yeah, like if you again, we really need help to improve documentation. I kind of like started creating this issue for folks to actually update the docs. So if you want to volunteer, just that will be great for us. If you can also improve the documentation while you just getting yourself familiar with this, new framework. Yeah, but right now, yeah, like you have to like explore a lot by yourself, unfortunately.
Okay, that works. Thank you.
Hello.
Yeah, Hamus.
Yeah, my name is Muzammil. You can call me Maz. I'm a CS undergrad student from India. I'm also looking into Project 8, I think, the Kubeflow and JAX runtime integration. And yeah, I cloned the repo. I can give you some like anecdotal tips, Nidish. So I cloned the repo and I just I've been asking AI code editors and everything to explain the integrations to me. I have a question for Xiao Wang, I think,
Mhm.
or someone from the Kubeflow team who's responsible for the integrations. Uh, so you know how we had you had implemented TF job and Jack's job.
Yeah.
So is the integration in another repo? Is it in trainer operator?
Yeah. So it's a trainer
Um,
operator. So yes, that's right. So take a look in the how we. So the thing is, like, we've done JUX for V1, the support last year, and right now
Yeah.
in the V2 I have a new model of this runtimes plus train jobs. So try to take a look how we did it for V1. Explore like the codes in the release branch, like release 1.9, and then you can see what is actually required for V2. Similar to Nidesh, you probably have to like explore a lot of like the proposal plus like the source code of how this framework, works.
Okay, so the Catab repository and the trainer operator sub repository
Yeah,
in
so
Catab.
you don't really need Katib right now. So Katib for hyperparameter optimization, like everything in
I
training.
think the trainer operator
Yeah.
previous implementation was in the Catab repo.
No, it's actually in the same
Oh.
repo in the Kubeflow/trainer, but in the release branch. So I have a release
Oh,
Yeah.
one.
okay.
We just rename the training operator to the trainer and
Yeah.
then move the source code of training operator to the branch released 1.9. You can check it.
Okay,
And
thank you for that. It's very
and
good.
we've implemented one CRD for one framework like JAX and PyTorch in the training operator. But now we use change-job plus training runtimes to unify all of them. That is trainer, also known as V2.
Okay,
Yeah, I would
so I
suggest
was confused
like
about that. Thank you for that.
yeah, no worries, no worries. Like feel free to like jump questions to the Slack. But again, I would suggest everyone who just try to understand what is Kubeflow Trainer, explore the proposal, and try to run some examples, and again feel free to improve documentation because we really require for other folks to actually get started with it, right?
Yeah,
um,
yeah.
right.
Thank you.
Yeah, anyone else before we get started? Maybe just want to just quickly themselves. um,
I, if no one else wants to say that, I just had one really quick question about what we just talked
okay.
about. So for the operator, I looked at the V1, which was the previous one, and there was two ways to implement the jobs, which was I thought through PyTorch, you could just directly do it in the code, or you could create a YAML file and then submit that as a
Yep.
job. So do both of those, you want both of those implementations for the V2 project?
Yeah. So yeah, basically SDK is abstractions on top of the Kubernetes APIs, right?
Yeah.
So at the end, you have to build the train job, which can trigger those JUX jobs, right? Not JUX
Yeah.
jobs, sorry, like the JUX distribute JUX on top of Kubernetes, right?
Yeah.
So you have to like do on the on the operational side, like with the CRDs, but also you have to update the client because the Python API is the main interface for all the users of Kubeflow Trainer, which means will be the work required on the both sides, on the server side,
Okay.
on the client side as well. Yeah.
Okay. Thank you.
All right. Um, Anyone else? Great. So let me just share my screen so we can quickly go through the agenda items. I know we have a few kind of things we want to talk about on the release side, right, Shao? I saw you added a few items there. Let me just share my screen quickly. Yeah, so I think for the release, thanks, like, by the way, thanks everyone for helping us to publish those images to GitHub Container Registry. So I think we're almost ready. We just need to finalize this the submission for 1.9.1, right? Uh, can you just maybe anyone tell me like what are the blocking PRs we need to do before we can cut the release?
Yeah, you're talking about specifically trainer or
Yeah,
Katiba as well?
let's start with training operator. Training operator on 1.9.1. So Shao, maybe you can help us with it. Like move
Which
to, I guess,
one?
this, yeah. So my
Yeah.
question is it the only one PR which is remaining before we can cut the release for 1.9.1?
Yeah, I think so.
One thing I wanted to ask, should we remove all V2 code in this branch, or is it fine to keep it there?
Yeah,
Because
it's
there's
it's
a lot of V2
yeah,
code.
I don't, yeah, I mean, we can definitely remove it. If Salish, you want to volunteer to do it, like, I think we can remove it. Um, but I don't think it's a blocker for us to cut the release, right?
I see. Okay. Yeah, then it's fine. I'll raise the PR anyway. Let's see if like it gets merged before.
All right. Any other items that we're missing in terms of the before we can cut the release? All right, so in that case, let me. So, Salish, you already updated all of the images back to the training prefix, right?
Sorry about it.
Yeah, no worries. Like, I think we can just clean up those images. So, my only question is for users, are we okay that we don't have v1 in the prefix for users of training operator? Because I can imagine the users of training operator will be. So, I think previously we discussed that probably we will support this for at least a year to 2 years. So this images needs to be maintained for quite some time. So I want to know, like, in terms of the user confusion. Yeah, good.
Yeah, I think training is similar to trainer. How about we rename it to training operator?
Yeah, this could be one.
It's more straightforward to users to understand what's the difference between training operator and trainer. And if we use training, it may cause some confusion.
Yeah, we can use training operator as a prefix. The only problem that we kind of used these images before in 2022. That is why this image exists in the GitHub.
Yes, also
I mean,
okay, but we should add some doc to tell users about it. It's, I think it's a bit of confusing. Trainer and training.
Yeah, we can definitely use training operator in the prefix here. Or we can use v1 like if to make it less confusing, right?
Yeah, that's a suggestion, but I'm okay with
So,
both options.
John, I can see you in the call. Like, what do you think? What we should do with these images? Okay, yeah, John, I think just dropped. But in any case, let's discuss this in your PR, Salish. Like, we can propose few options.
Yeah.
And then maybe because, like, again, we have Ivan in the tech, right? But at the same time, we
Yeah.
don't want to confuse
Nice
them
thing.
with the same name, right?
Correct. Even if we put training operator, now this image will become training operator / training operator.
Yeah, I understand. Yeah, let's propose few ideas and let's make a decision on this, 2544 PR, right?
Got it.
And then we can cut the 1.9.1 release. All right. So, any other things we need to cut before this release? Okay, then I guess let's finalize 2544, and I hope we can cut it this week. Like, because I think like it's kind of like blocking release team to make the official Kubeflow 1.10 release. I don't know if Ricardo can do it before the KubeCon, but otherwise we can at least give them the release candidate before the conference will be there. All
One
right,
more
so
thing, they
yeah.
specifically called out the Katib migration PR. So
Mhm.
Katib has a lot of images, right? So they
Yep.
wanted that also.
So let's finalize on the Katib side. So which PRs we want to postpone and which PR we want to merge before the release. So moving to GHCR, right? This one.
Move to GHCR currently lacks. We still need to update the image in the examples and other areas. But it will stay there we will do it in the tomorrow or recently.
Okay, Madi, do you think you can finish it today, this PR?
Could you go again? It is the manifest thing?
Yeah, like because this PR is blocking us to cut the release for Katip, right?
Yeah, I can work on it after this meeting.
All right, so then I guess because we already published it to the Google GitHub Container Registry, right? So the only remaining things it's
Yeah, I
about.
will. Yeah, I will do that today.
All right, sounds good. So then I guess other PRs maybe we can postpone. Like I know we have some issues with unit testing for LLM for what is it, like the PR for volume mounts, right? And also for fine tuning this one, right? E2 test. I would suggest maybe, I mean, if you don't have any concerns, we just can, notify the contributors, and if they cannot finish it by tomorrow, we will just cut the RC. So not RC, but official release.
Yeah, for sure.
Any objections with it?
No.
All right. So in that case, we can make a note here is to set current injection. This pod security policies. I guess we still haven't find the consensus, right, on the warning side. And this one needs to be merged today. Okay.
Could you also add that warning in the manifest as well, which Julius was working on?
Can you remind me what is the PR number?
I will look at it.
Yeah, pod security. Is it this one? The pod security policies, right? Oh, it's actually.
No, it's not.
Oh, no, it's for security context. You mentioned Istio. I remember there was some PR for Istio set car injection. This one.
No.
So we add the end-to-end test PR to the list. The GSOC, yeah.
Yeah, the number is 2511.
Yeah, I see. Yeah, so what about this one? Have you got a chance to verify it so we can?
I cannot do it tonight. Maybe if it's possible for the next one, next release.
Okay.
Thank you.
Yeah, that sounds good. In that case, let's focus on this 2529, right? And if we cannot merge any other PRs, we will just cut the Katip release this week. All right, so we have a few things also to discuss about the manifest. Do you want to talk about this one right now, or we want to talk about this LLM trainer updates that we've been working on in the last 2 weeks?
I think so. We can discuss about the manifest first, and I will introduce the updates in the LLM trainer.
Okay.
Hi,
so,
Ximing.
Yeah, go ahead.
Yes, I think the PR 25 and 27. Yes, it's I just opened this PR and I'm now working on the E2E test, and I have some questions for the E2E test.
Yeah,
It's
good.
about maybe it's about the path problem, and I think the E2E test we use kind to create the cluster. And maybe is that different from the just from the Kubernetes cluster?
No, I think it should be the same. Do you see any errors, like problems, while changing the manifest and using kind cluster? Because kind is just local Kubernetes cluster running in Docker runtime, right?
Yeah, hand-to-hand tests
I
have
feel some
failed.
problem yes, I feel some problem when I create the runtimes, and it just can't find the CRDs. But from the log, I can see the CRDs created. Yes, I just can't reproduce the problem in the Kubernetes cluster. So I'm wondering if the past problem.
Yeah, I would suggest try to run this kind cluster locally in your machine and see if this actually can be reproduced. We have this even action, right, for you to bootstrap the kind cluster. So the action called make, I think, test E2E setup, right? So I'm talking about this script. You can try to run it locally and see if it works for you, right?
Yeah, thank you.
Yeah, because that will create a cluster and it will load images. Yeah, because we need to figure out like whether this ordering approach is going to work for our E2Es, right?
Okay, and another PR is the Kubeflow platform, and I think it works fine when we put the runtimes before the webhook. And I think the FIFO, first in, first out, is more safe. So any suggestions for this PR?
Yeah, I would suggest let's make the E2E working. And once we figure out that we can merge this overlay for Kubeflow platform, right? Because the same overlay, the same kind of the same way you're submitting the resources, right? So if you make your previous PR working, after this we can make sure that this overlay also going to work in the manifest installation, right?
Okay, I see.
Yeah. I'll help her look into it.
Yeah, I think it's fine. It's like we no need to rush for this, right? Because like we haven't released the trainer yet. I really hope we can release it before KubeCon, but the problem is like we need to do some still work for MPI. Just to give you updates for MPI, I think we've done a lot of great progress last week. Actually, Yuki implemented the MPI plugin, and right now we even have this workable MPI runtime for you to try out. I'm already was able to, I was able to actually use this MPI runtime for MLX, which I will try to prototype in a KubeCon and show this as an example. But also we're working right now for deep speed, which means like, this MPI implementation right now is just working, and we just need to make sure that we can, integrate with SDK. Yeah, so if you're interested, take a look. But I think like this, the API, like one of the biggest kind of goals for us to achieve for this project, because by default you cannot run API workloads with job set. So it's definitely like the things we should be like release when we make this first 2.0 release for Kubeflow Trainer.
Hey, can I
Yeah, also,
ask a question on this?
Yeah, go ahead, Sean.
Yeah, so could you summarize the discussion around the implementation of this? Because it feels like you want to implement this using the pod spec overrides, or is there a separate approach that you're thinking?
Yeah, it's a good question. Let me actually, yeah, we talked a lot about this with Yuki last week. So just to give you the context, so the problem is like with MPI, usually, and let me maybe open the updated PR so it'll be easier to understand. So MPI has the concept of launcher and the concept of node/worker. So when you want to run your distributed training with MPI, you have to configure two different templates. So just give me a second, let me open the template. So one of the template is actually the template for MPI launcher, and one of the template for actually training node. So the problem is compared to Torch, for example, you don't have two different templates. So you have only one single template. So just like to give you an idea. So this is the YAML for Torch. So as you can see, it's very simple. It's just, single replicated job, which has the name of the node and which has the training container, right? But for MPI, we have two replicated jobs. So the one called launcher and the second one called node. And why we do this? Because in the launcher, we need to run MPI run command, which is defined right here in the launcher container. And in the node replicated job, we only need to start OpenSSH server because what is happening during the orchestration, we start this cluster, right, MPI cluster, and we inject the host file plus the SSH keys, so launcher can actually SSH to the nodes and perform MPI tasks. Which means like it's completely different on how we do this with Torch, because Torch run basically doesn't require for us to do SSH before when we actually run Torch run, because everything is over the network. So the tricky part, because we have two different templates, like one is called launcher and the second one called node, we don't really know how to propagate parameters from the train job to this to the job set. Because in the first example, you have this single replicated job called node. So we basically can say if the replicated job has this name, we're going to propagate the values from train job to this template. But in the second scenario, we need to propagate information from train job not to the node, but to the launcher, to this template. So the question is how to define where, like in which stage, like in which replicated job, we need to propagate parameters from train job to the job set. So this is the context. Any questions? It's maybe kind of like complex, but does make sense?
Yeah, no, I mean, a little bit, I think so. So, could you go a little bit up in this? The
Yeah,
line 5, line 6. So here,
Yep.
So say this is an MPI distributed cluster training runtime, right?
Yep.
So what if we had deep speed MPI distributed cluster training runtime, and then you make whatever changes to the launcher?
Yes. So for deep speed again, with deep speed we don't need to even right now create that different ML policy. We still can use MPI ML policy, but we just need to change the entry point for the launcher. So it will be still MPI run, but it will be slightly different in terms of the arguments, right? But we can still use pretty much the same template as we have here, but changing some of the parameters. But we still need to propagate values from train job to the runtime. The values like, for example, commands, right? Like user configuration, like user arguments, right? Like parameters that user can define via the train function, right? The training function by itself. We need to propagate the training function to the launcher, right? Yeah. So this is possible. So how we achieve this, and this is like one of the ideas I think we kind of agree upon too, and we are looking for any other ideas, like if any other folks around community have other opinions. But we introduced this new label called train job ancestor step. So what this label actually defines, it defines the relationship between train job and the runtime. So if you take a look at how train job looks like, how train job is structured right now, so train job has train job API I'm talking about. So it has this spec, right? It has initializer, and it has trainer. It also has other parameters, but they're not relevant to this use case right now. So what we want to say with this label, we want to say that if this label presents on the replicated job, we know that the parameters from train job from trainer needs to be propagated to this template. So this is sort of define the relationship for us to propagate those values from the train job to the job set, right? And that is why in the MPI use cases, this label defined on the launcher replicated job, but on the Torch use cases, this label defines on the node replicated job, right? And then in our orchestration, we understand how to do this relationship, right? And how to do this overrides.
I see what I mean. So
yeah, go ahead.
I mean, one thing I think is that if you had the bot spec overrides, you would have the ability to target a specific replicated job.
Yeah.
Then you wouldn't need this label.
I think that's right. I think the goal of our pod spec overrides was different. So the initial goal of pod spec overrides is to provide additional parameters on top of trainer. Because trainer API, it's very limited right now. So trainer has only image, commands, arcs, environments, number of nodes, resource per node, number of. So this is the all parameters trainer has right now. So it's mostly like ML user facing APIs, right? We don't want to expose entire job spec to the trainer, to the user, right? To the ML user. But at the same time, we understand that sometimes in some like very specific use cases, users require to override some of the parameters on every train job submission. Like for example, you might have a single runtime, right? Which has the persistent volume association, right? But you want to inject the volume mount on every time you submit your job set. So we don't want to add this API on the trainer side because it's really, really tricky to support like all different use cases. So for this kind of scenarios, we introduce these pod spec override APIs. So the goal of pod spec overrides is different compared to goal of the trainer. Does make sense? Maybe let me open this proposal to make it more clear.
I understand. I understand the goals were different at conception, but
Yep.
it does feel like a valid use case for pod spec overrides because, I mean, like for instance, if you had one label, then from a pure API perspective, at some point you would want that to map to multiple such replicated jobs. Like I would think that at some point you'd want some parameter to also override launcher and node and another something.
Yeah, like
so it has it could so ability to target multiple jobs will probably be lost if you use the label approach.
Yeah, I think we also discussed this, like ability to override multiple templates from the trainer to the job set, right? We just don't really aware of such scenarios when trainer parameters needs to be propagated to the multiple templates. Like as far as like we know, like from TensorFlow, JAX, or Torch, there are not a lot of use cases when like function needs to be propagated to the different templates. But
I
again,
mean,
like
for example, the simple ones like environment, those need to be targeted multiple jobs, right? Like just some secret environment you need to inject in every replicated job. That's a case where you would target multiple jobs.
Yeah, but for this we have pod spec override, right? We don't
and
even
now it has to work with additional label and see and then kind of solve the contention between what label does and what this is supposed to do. And behavior is complex, is my point here.
Yeah, so the thing is like if we kind of rely on just pod spec overrides, we don't even need trainer at all, right? So trainer API.
Because not to that extent. I mean, right, that not everything should be exposed to at the train job level. So we have to make a conscious choice on what should be exposed and what shouldn't. So you're right that, I mean, right, for example, one of the examples were the node selectors, right? So you don't want probably to let users choose a node selector. That it must be at the platform ops level.
Yep.
So that could be in the trainer, but the overrides is maybe a small subset of what you could change. Maybe
I think So I think the goal of introducing trainer is kind of a high level API, right? I agree with you that pod spec overrides basically can implement everything. We can remove literally everything from train job spec, from everything from here. I mean, not here, but from what is it? From train job spec, and only keep pod spec overrides. Like we don't even need anything else, right? Maybe we probably require only runtime reference because we need to fetch the runtime, right? Like we don't need initializer, we don't need trainer, we don't need suspend or manage by or labels or annotations because everything can go to the pod spec overrides. The trick is like, yeah.
Right. No, I mean, I don't think I agree because the persona differences, that's all. I think if you bring persona differences into this, then you would want train job spec to be separate from pod spec overrides.
Yeah, exactly, right? So the persona is different. So we speak about ML user persona, they kind of they say, I want to configure this trainer, right? And like it's up to us to understand where this trainer needs to be configured. I mean, not like us and platform engineers, because like ML user probably don't even know how API implemented, right? They only know like I have this trainer, I have this number of nodes, I want these things to run, right? That is why I don't want to use pod spec overrides here, because that will force users to understand the pod spec overrides, right? Because users, I mean, I said like the primary interface is the Python client, right? It's not like the YAML, but we just want to make this YAML also very kind of ML user focused, right? Because like like pod spec override should never be touched from the ML user perspective. This like I think what we want to say in any use cases. That does make sense.
Yeah, I see what you're saying. So,
it's mostly like a system parameter, right? It's like we kind of introduce this because we have this kind of edge use cases, right? When trainer and initializer is not sufficient APIs.
Right. So, but I see. So, how do you justify the use cases where you want to just change some launcher command? Or you mean the Python client can actually change the YAML somewhere?
No, so
like, yeah.
So yeah, the Python client is only, I think, do we have an example to train job? So Python client will only configure the train job, right? And the train job, for example, this one, right? So this is a torch, but train job has this, command, number of nodes, and image, right? And we know due to this ancestor label, we know how to propagate those parameters to the launcher, right? Or to the nodes, depending on this label association, right? So we don't even touch pod spec overrides here, right? Everything is under trainer, right?
Okay, I see. And that's I see. Okay, what are you saying? Okay, so
yeah, even for API, right? I mean, I agree with you that probably use case when both replicas needs to be override, but I think in that case we can apply labels to the both replicas, right? To the both replicated job if that is required. For example, like you might have two TensorFlow parameter servers, which requires two different templates, pod templates, but you need to propagate your image to both of those templates, right? This might be useful, right? We're actually thinking the same way on the initializer side. We're also introducing this label on the initializer side, which means like we kind of know how to propagate values from initializer to the template. Because, for example, you might have more kind of complex initializer, which has two different replicated jobs. Like I think we discussed with cache scenarios, right? You have like your head node and the worker node. Maybe you want to override your initializer only for the head node. So this also could be different scenarios how we can propagate those values, right?
Yeah, I mean, like if that makes sense, but let's say if you forget about what pod spec overrides is today and just translate the label, whatever you want to describe through the label, make it into a proper API.
Yeah.
Like
yeah, go ahead.
Like you don't have to provide any overrides in general, but just provide that mapping that you want to specify through the labels into a separate proper API. It'll be more intuitive.
Yeah, I think the trick with that, what if you have custom job sets with part of job sets we don't support, right? What if you have like post-processing job, which we don't really orchestrate, and user doesn't really know about, right? A system like the post-training step, which will do some analysis, right? and you kind of like need to override it on the system level. So you cannot achieve it with the existing train job API today without pod spec overrides, right? Like it could be some scenarios when trainer, like when where like this API is not sufficient, trainer and initializer, right? So these two APIs for more kind of like complex scenarios. Yeah, it does make sense. Like,
well, I mean, again, it's in that territory where we want to find out that exact use case.
Yeah.
But
I agree.
But we would, I guess, but having a proper API. I mean, if you just showed the pod spec override spec, right, and you just remove everything, just do target jobs, for example, just naively, you would get that label functionality what you want to achieve, and we could expand that somehow with new use cases. Seems reasonable that way. And we didn't, let's not call it pod spec overrides if it causes some friction with the experience. We'll figure out a name there but essentially something more intuitive that tells the Python client and the user ultimately that this has to map to the launcher, this has to map to the node, things like that.
Yeah, another idea might be like to introduce target jobs to the trainer API as well and the initializer.
Yeah. Right. That's simpler actually. Yeah. Also, yeah. But unless you want to expand that, you want a container on the top of it.
Yeah. The trick is, if we kind of like introduce this pod spec override target job to the trainer and to the initializer, right? Not pod spec, but target job, right? APIs. That might solve this kind of issue, label problem, but who will populate this parameter, right? The user will be responsible, right?
Yeah.
So it will be on the train job side, which is on ML user side, right? So it's kind of, I think it's good.
Yeah, good. Yeah, no, I think one of this aside, the other concern with label is it's supposed to be like an indexed key, right? So it doesn't seem like it's a right fit for that. So we should think on those lines as well.
Yeah. I think we also discussing the API with Yuki, but it's kind of, we require more kind of deep discussions, like what is the right approach here, right? Like API on the trainer runtime side. Maybe like the relationship between train job and the runtime can be defined somewhere in the API of the trainer runtime.
Yeah, it's possible.
But yeah, let's definitely follow up on this. I think like, we have few use cases. Let me make a note. So API, because if we introduce this job target, what is it called? This API target jobs, right? Yeah, target jobs API on the train job level, right? So then I guess like the question is like, who are going to populate it? User will be responsible. So we need to somehow provide some sort of defaults. But anyway, I think we can continue this in Slack to see if this label approach is not sustainable for the long term.
Makes sense. I think someone else also jump in. Not wrong.
Yeah, go ahead. Anyone have a question? I know it's kind of hard to understand, but we kind of like been struggling with API support for train job a little bit.
So I had a small doubt. The MPI distributed YAML. So like, what if, so there's the launcher and the node, right? And now you're saying that the user's arguments or like any changes they make to their train job will be propagated to the launcher.
Yep, that's right.
Does.
That's right.
Will there ever be a scenario where they want to propagate different arguments to the launcher and to the node?
Yeah, as far as we know, as far as we aware of, no. Because node only start open SSH server, and it doesn't require any parameters to be propagated from the trainer.
I see. And this will be true for any training runtime? Like
for deep speed, at least for deep speed plus MLX, yes. We haven't explored other API-based runtimes, but as far as we know, no. Like, yeah, they might,
I mean, having said that, I think it'd be nice to maybe future-proof it. But that's the benefit of API. If you do labels, then it'll definitely become quickly overloaded. So I know we don't have full use case right now, but thinking having a proper API would help us kind of go forward as well. Because
yeah, I agree. I think we just need more time to design it. We just didn't get time before our demo. So, but maybe we can redesign this label approach to something more future-proof, and more extensible, right? But let's definitely follow up on this. I think it's a very interesting, problem to solve, especially how a replicated job can be complex and how we can address different use cases. So let's talk about it more. Async. Yeah, so I know we have like 5 more minutes and we have 2 topics to discuss with UV, and I also want to share like my updates for the runtime object. So for UV, who added this discussion on this call today?
That was me.
Yeah, hi Seth.
Hey Andre, how's it going?
Doing
So
good.
Sorry.
Go ahead. Do you want to share your screen or do you want me to share this?
Well, you can share if you want. So what I've done here, I've used UV workspaces and I merged the trainer clients and Katib libraries. They actually both work. I tried the same stuff locally on a cluster. I can do a quick demo if you want, and both are working fine. So if you open Kubeflow, you will find 2 nested projects underneath this SDK, and we have I actually named it to Optimizer instead of Katib, so it's now all Optimizer. I didn't copy any open API generation code or stuff like that. I just wanted to demonstrate that's gonna work okay, and I was working on a small quick patch on the pipelines to copy it over as well to just show like things could work. They do keep their own pipe project, the TOML file, but the main dependencies are added to the root one, and they all share the dependencies. There are a few tweaks and hacks we can do and implement to maintain all of them in the same repository under different like workspaces. But yeah, I think it's a great feature we can rely on and we can implement it straight away. This is, by the way, this is the key you have here. It works completely fine. And no issues.
Yeah.
The nested pipe project .toml files is not important. The main important one is the one at the root. So if you go to the root, there should be like, yes, this is the one where we publish. Here for the version stuff, I just used that trainer one, but we can add nested ones for different versions. If we would like to keep different versions for different workspaces or different like libraries underneath the root library, we could possibly do it. We still need, unfortunately, a build system. So I'm using here the hatchling build system for this one. So it is a default one. If you don't specify any under UV, it will default to hatch or hatchling.
Yeah, I think this is amazing. So a few questions. Like in terms of workspaces, they're only overriding the dependencies, or they also like you can install it individually. How does it work?
We don't really install it individually at the time. So like here, when I published a fork of this on my personal PyPy Python packaging indexing, and all of them gets installed because here, if you check the dependencies, you will find it relies on the workspaces. We actually add the workspaces here as the trainer, and like you can check line 15 trainer, and optimizer is line 17. And in the sources down there, I say like fetch those from workspaces. They are actually nested workspaces within the code. So you kind of tell these dependencies are available inside. So not 924 and 2526. They are nested dependencies in a workspaces. So that's kind of tells UV, don't go and find these codes somewhere else or from pip or anything like that. It's available locally for you. If we need to publish, like UV actually provides a pip compliant dependency group, so we can define as many dependency groups as we want. Optional dependencies, so if we want to make them installable on a separate basis, we can do that with optional dependencies, which represents extras. But yeah,
I see. So, but I see. So basically indicates that those dependencies lives in the workspace, right? Live in the workspace.
Yes. Yep.
And what other features gives us those workspaces? Like, can we define the? I guess like when we do pim install Kubeflow, it will install everything, right, for us.
Yes. So you can add workspaces that are not nested locally or directly as a source or not packaged. You can also define, well, you can define dependencies, but they recommend like you keep all the dependencies in the root one, or it will be all in a same log file. So simply it's going to be like single dependency for the whole project. If we need to read them like separately as sort of extras, then we'll add them as optional dependencies. UV is super fast and can work with multiple Python versions. I happen to use just Python 13 here, but I have another PR where I moved it, or I have another local change when I moved it all to Python 3.9.
So can we do something like, pip install Kubeflow trainer and only install the wheel from the trainer if we don't publish it, like, because the extras are only install the dependencies, right, not the wheel.
Yes, so that's like we keep the dependencies in the root, so we'd have to install everything. But if we need to structure it differently, there is a possibility we can structure it this way. Like if you want it this way, this is what we call extras, like Python extras. I can define that in the same PyPy project and define it as optional dependency. But yeah, it is possible.
Yeah, and I guess the wheel will be installed only with trainer if we do this, right? With workspace approach.
Yes, the root and trainer. Like if the idea is to have in the root, like Kubeflow root package, you could add like a sort of common code or anything like that. You could also add a workspace, which is not really a workspace, but like common code or whatever, and then you would have that plus the trainer, and you don't have anything else.
Yeah, I think it's great. Let's definitely talk about it more. Like, I mean, I agree with you. Probably we should have common dependencies because folks would just want to do pim install Kubeflow and don't have any problems with dependency management. But at the same time, we just want to see whether those extras will give any value, additional value, right? For folks who maybe just want to use trainer, for example, or maybe want to use pipelines.
Yeah, so we need to resolve dependencies if pipelines are going to rely on the SDK or like which project, like inter-project dependencies between trainer, KFP, optimizer, and so on. Because actually optimizer is relying on the Kubeflow trainer. So the optimizer is loading in its dependencies. It requires the trainer. I didn't add any of that here. Again, it is in the root. So any internal dependencies is kind of resolved automatically between all these projects since they live in the same place. If we move to extras, we would have to put dependencies between the extras and each other, if you know what I mean. So optimizer would require trainer. So if you're installing pip install Kubeflow of optimizer, like between brackets optimizer, this will mean you would have to also install Kubeflow trainer as well.
Yeah, I think that makes sense. Francisco, you want to say something?
No, just how we manage this in Feast, because we use UV and handle this. We export requirements files and then have everything pre-resolved. UV is very fast at this, and so during development, that's what happens. But there's nuance here where if people also add stuff to their own local implementation of whatever in the client, then sometimes that can get a little bit more complicated. Yeah, I do think that the extras is probably how I'd really recommend it.
Yeah, I think we need to figure out whether this workspace approach might be useful for us from the short term to the long term, right? But in any case, I guess like UV is a great thing to give us a lot of opportunities to, like to make it faster, right? And the build system and support multiple Python versions, right? So let's definitely so let's follow up on the cap.
Sure.
And I think maybe after, I don't know, I don't think we need to be in rush, but maybe like around KubeCon after time frame we can discuss once we make this official first release, how we can leverage UV and what features we want to leverage initially, right?
Definitely. Just one quick question here. Would it make sense to use UV as a package management for our runtime implementations, or do we stick to pip since it is super fast?
Yeah, instead of installing the dependencies on the training functions, right? Like on the when we do. Yeah, it's a good question. So what is required? So we require to have UV installed, right?
Yeah, well, it will be in the base image, like you have UV installed, and then UV would take care of installing dependencies and making them ready.
Yeah. The thing is, like, what we do today, and I know over time, like, feel free to drop, like, we just maybe have like 2 more minutes, but we pre-install similar to KFP. I think we're doing exactly the same approach as doing the KFP, but basically, if the PIP is not installed, we just ensuring that the PIP has been installed by us. So we do apt-get, and this does not work for everything, right? Because if you're using DNF, this will be just broken, right?
Yeah.
I would love for us to figure out the way how we can make it, like more generic. But maybe I think it's if UV is how UV can be installed and what are do they support everything, right?
It's a bash script or a curl command, like it would fetch the latest from latest binary for UV. Another quick thing which is like related to this is like right now when I use a runtime, I don't actually have any way to extend this runtime, which means like if I'm just using a set of libraries which is defined in the runtimes, and it happens to have a libraries that I would like to get installed on the runtime, there is no way to do this. Are we looking at extending, or is it?
So
there is a way.
Okay. Using packages to install, right? So I have this similar to KFP.
Okay.
It's
But
like exactly
that's
the same. Yeah, good.
Sorry, you provide a list of packages, or you provide like?
It's basically we even have an example. Yeah, Antonio, go ahead.
Just a quick point. I'm not familiar, so maybe my question will be completely off. But on the question on the base image, like for downstream project that would like use pip or whatever package manager to install like pre-installed packages. Like would UV be compatible with that? If we adopt it like in to implement the package to install. I guess if I ask the question differently, like what if we adapt it for implementing package to install, would that become a requirement for downstream project to use to build their own pre-built runtime images?
Yeah, so and PEEP also like requirements, right, Antonio? So even if they want to use packages to install today, the PEEP has to be installed.
Yes. Okay.
Like the problem is yeah, good.
Yeah. So I mean I'm not a Python expert, but PEEP I would say it's all right. If we choose to use UV, like would that be okay?
Yeah, I think this is what we need to discuss, right?
Yeah.
So how like well it is adopted for different images, and whether like we see more errors when UV cannot be installed for some architecture, like, for example, like
absolutely.
Dora or
I'm not like having any strong opinion. It's just like it is a point like for downstream project.
I think it's interesting actually. I also thinking about it like when we discuss this UV approach, because KFP also rely on PEEP today, and KFP using this for lightweight Python components. So if we feel that UV can help us to address those problems of installing packages before the runtime, before the job being created,
I
think we should just make this statement, right? Or make it like, configurable somehow, right?
Yeah, true. Yeah.
Cool. We can follow up and we can have a discussion around this one. And I don't know if we need to write a KIP for that, but
yeah. Let's definitely. So I think after KubeCon, let's definitely have a demo for like what you've done for UV and what we can do for the long term. I would love to learn about it, but especially on the workspace side as well. But I think it's great. I think we definitely should, improve our build system. And if this actually can simplify life for people, for users to manage dependencies, this will definitely help them.
Perfect. Thanks, Andrew.
All right. I know we're over time, so I just want to talk about runtimes, but maybe we can asyncly talk about it. But Shao, like, I kind of did some updates for the runtime object, especially for this discussion with MPI. So maybe after the call, if you have time, please take a look at my PR. And just let me quickly go through the object. But the trick is like we need to improve the runtime object in the CRD, and I want to know, like, understand like whether this makes sense to you, the runtime object, because we need to understand the entry point for different runtimes, for different trainers, like MPI based, storage based, storage tune based. So I've done some changes in my PR. I will ping you once it is ready. But maybe we should be a little bit revisit the runtime object from the SDK perspective. If that makes sense to you. Talking about this runtime.
So we discuss some of the labels in the runtime.
Yeah.
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 Please ping me. Please ping me. Yeah.
Let me ping you. Let me ping you in the PR and just specifically tell you what changes I think might be required, and then we can follow up on this to see whether you can also update your PRs for LM trainer. All right?
Yeah. Oh, okay.
Sounds great. Yeah. Any last questions? Sorry for keep you 5 minutes long. Sounds great. Thanks so much for your time, and it's a great work. It's a great thing, and a lot of things will come to the KubeCon. Stay tuned. I'm super excited to share all the work we've done, and let's definitely follow up after this great demos, to see how we can adopt this new great framework for more people. So thanks everyone for your time. Speak to you soon.
Thanks, everyone.